This is the Molecular Foundry. It is a knowledge-based user facility.
That means we help scientists pursue research goals that are not possible at their home institution.
These scientists are called users, and they come from all over the world.
Here, users are free to use some of the most advanced pieces of equipment in the world, like microscopes that can see individual atoms in 3D, or robots that make nanoparticles.
The Foundry is also home to some of the leading experts in fields ranging from chemistry, physics, biology, engineering, and materials science. And these experts partner with our users on their research projects.
The Molecular Foundry was founded in 2006 with a dream to
be a resource to the entire scientific community,
To be a leading research institution,
provide a model for team science and show what can happen when you bring together so many disciplines and tools under one roof.
While many of these dreams have come true, we still have a long way to go. The Foundry is a relatively young institution, and many scientists don't know about us yet.
Despite these obstacles, the thousands of users who have worked with us are taking our collaborative way of doing science back to their home institutions.
person by person, lab by lab. We are changing how science gets done, and atom by atom we are working to change the world.
The Molecular Foundry was created to ensure that good research ideas, wherever they come from, have an opportunity to be explored. By allowing any researcher with good ideas to come and use the Molecular Foundry for free, we're working to make sure that good ideas can have an equal chance of success. For example, this is Nick Boris. He is a Foundry user because his institution doesn't have the expertise to develop the nanofabrication protocols that he needs for his research that could lead to new quantum technologies. Another example is Hope Ishii. She comes to the Foundry to use our world-unique electron microscopes to study comet dust and explore the origins of the universe. The Molecular Foundry supports over 1,000 users from over 30 states and over 30 countries every year. These researchers, in partnership with our staff, produce nearly 350 peer-reviewed scientific articles annually. Our teams of Foundry staff and users are working on several promising projects. One example comes from a user named Annalise Barron from Stanford University. She partners with Foundry scientists to design and make biocompatible polymers that are called peptoids. Recently, she used the Foundry synthesis robots to screen a large number of peptoids for activity against SARS-CoV-19 and identified one that has the potential to act as an antiviral agent. This promising peptide is now undergoing further testing. When it comes to fundamental research, it can be very difficult to predict which one is going to have the most impact. Sometimes the benefits of research are not known for many years. However, in the case of our users from industry, the societal benefits are usually more tangible and timely. Let's take the case of our Foundry user, Xiaoxi Wei. She's the founder and CEO of Xtherma. Xiaoxi and her company are using the same peptoid technology to advance the field of regenerative medicine. They've created a bio-inspired polymer that can prevent ice formation in frozen cells and tissues and organs, aiming to solve the challenge of storing and transporting living tissues in order to save lives. The Molecular Foundry specializes in nanoscience. Over the years, we have built the tools and the expertise to see, to build, and to understand materials and devices atom by atom and molecule by molecule. This level of understanding and control opens up nearly unlimited possibilities for reaching new frontiers. And in the next few decades, we're going to work with the community to devise new materials that are designed on the atomistic level, on the nanoscale, for technologies that will help us solve our community challenges in sustainable energy production and storage, recyclable plastics, and health-inspired molecular biomaterials.